So we are going to take, we had 2.4 yesterday. We're going to take 2.5, we're going to break it up into 2 different days. Then on Thursday, we'll do a review activity. And then you'll have a quiz on Friday of this week. Okay? Okay. Love it. And again, if you've got stamps or homework to be stamped, that's great. Make sure you get that stamped at any point in time, and then get that stay current on your homework stuff. All right, here we go. So we are in your packets today. Little retrieval action here. So let's do a little simplification for the first 4, and then find the indicated values given those 2 rules there. Finding some other stuff with that, with those rules, love it. Okay, so let's do the retrieval at this point in time. Now, which is on page 20. Page 20. I get 3 square roots of 2 for part A. Yes?
Yeah.
Okay. I get 5 square roots of 3 for part B. Yes? I get 4 square roots of 5 for part C. Yeah? Mm-hmm. I get 2 cube roots of 3 for part D. Yes? You can ask, it's okay.
How to do that? Yeah.
Okay, all right. That's great. That's great. So yesterday, remember, I know it was me on a video, but remember how one way was I gave you like this way that I just did blue, okay? And then the other way, we looked for pairs because they were square roots, right? Okay. Well, now because it's a cube root, I'm not going to look for pairs. I'm going to look for triples. Okay. All right. So 24 here is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So I'm looking for triples. That gets me my 1 that comes out. And then 3 is not a triple, so it stays in. Okay. Good to go on now? All right. Function find indicated values. So finding f of 3, that's going to be then, so f of 3 is going to be 5 times 3 minus 8. 5 times 3 is 15. 15 minus 8 is 7. So f of 3 here is 7. Agree? Okay. F of x equals 27. So now I would say 27 equals 5x minus 8. I would add 8 to both sides. That gives me 35 equals 5x. Then I would divide by 5. So that's where x is 7. F of negative 2, plug in negative 2. 5 times negative 2 is negative 10. Negative 10 minus 8 is negative 18. Agree with me on that? Okay. G of 4. So now we're going G of 4 4 to the 4th power. 4 to the 4th power. 4 times 4 is 16, times 4 is 64, times 4 is 256. So this is going to be 3 times 256, 70. So 8, carry the 1, 6, carry the 1, 768. G of negative 1 would be 3 times 4 to the negative 1 power. Well, that's going to be like 3 times 1 over 4 to the first power, so just 1 over 4. So that's going to be 3/4. Find it when it's 12. So 12 equals 3 times 4 to the x power. I'm going to scroll down now that I got it. Nope, hit the brakes. Scroll down now that I got it. Divide by 3 first. That's going to give me 4 equals 4 to the x power. Well, what's really my exponent here on just 4? 1. So that means then that 1 has to be x. Okay. Questions, comments, concerns, clarifications? All right. Jump into it here now. Let's go. Carlos and Clarita have been working on their math together and noticed something interesting. Carlos, I've been looking at the graph of f of x equals 2 to the x power, and that is the graph there of f of x equals 2 to the x power. And he's trying to make sense of the graph when the inputs are negative. Here's what he sees on the graph. Okay, so it's there. What observations can you make about Carlos's graph, especially when the x values are negative? First response. What do you see about Carlos's graph, especially when the x values are negative? What do you I agree with the nonlinear part because it doesn't make a line. Okay? What do you mean by positive? There can't be a slope, it's not a line. You just told me that. I like the word positive, I just gotta want to know what the context is of it. You understand what I'm saying? Anybody want to jump in on that? It's positive.
It's going up instead of down.
Okay, it's increasing. Okay, that would be one. That would be one way to say it. Is that what you were going to say too? Another one about the positivity of it. Look at the graph. If you want to look up here, you can look at your own graph, which is on your own paper. Anybody come up with another positive that we could, another, I don't want to say, explanation for the word positive? By looking at the graph? Is that a true statement? a true statement? Yeah. Why is that a true statement? Why? You are correct. Why? It's always going to be positive, right? It can never be negative. And it can't be zero either. Because the only way it can be zero is if 2 was 0 and 2 is not 0. Yep, exactly. So it's going to get infinitely and infinitely and infinitely closer and closer and closer and closer and closer. Thank you. But it'll never actually become 0. Okay? Love it. Clarity. Sometimes it helps to make a table to look for patterns in the numbers. I'm going to try that. Complete Clarita's table, making sure your table matches the graph. Okay? So what are we doing? So let's work left to right here. What are we doing to go to get the next term to the right? We're multiplying by a half or dividing by 2. Okay? All right? So we're multiplying by a half or we're dividing by 2 to work our way that way. Okay? So now let's pick it up at 1. That pattern would still hold. So what is 1 times 1/2 or 1 divided by 2? 0.5 or simply a half. Yep, exactly. 1/2. Love it. Okay? What is 1/2 times 1/2 or 1/2 divided by 2? 1/4. Yep. 1/4 times 1/2 or 1/4 divided by 2. 1/8. Yep. 1/8. Okay. And what would the last one be then? 1/16. Yes, exactly. Okay. All right. So let's go back to that number 3 one that we just talked about. All values of f of x are positive. The graph is totally above the x-axis. Why would Clarita's never have 0 or a negative number then? Because what? Honestly, I couldn't hear you. I honestly couldn't hear you.
It says they go 1. That was the 1 fraction. I don't know explain this number.
Well, let's go back to what we're doing to get that next one to the right. What are we doing?
Just dividing and multiplying.
Okay, but let's pick one of them. I don't care which one. Divided by 2. Are you dividing by a positive 2? Yeah, okay. So a positive divided by a positive is positive. Could it ever be negative? No. That's why it would never be negative, right? We could flip that around to multiplication too, right? A positive times a positive is always positive. Okay? So it's never going to be negative. It's going to get smaller and smaller and smaller and smaller, but it will never be 0 and will never be negative. Carlos, so here's what I think is really strange. Look at the graph for 1/2 to the x power. Okay, so now the first graph that Carlos did was g of x, or excuse me, f of x equals 2 to the x power. Okay? Now we're looking at 1/2 to the x power. Okay? So let's compare those two and what similarities and differences that we have. For you, luckily, they're right on the same page. So we're looking at the two graphs. Similarities, differences. No umbrellas in this brainstorm. Go for it. Shut one out when you think you see one. Comparing the two graphs that are on page 21. Both are nonlinear. Both have positive values for all of their numbers. Yep. Mm-hmm. Remember, it could be a difference also. It doesn't always have to be a similarity.
One is increasing, one is decreasing.
Which one is increasing?
The first one.
The first one was that f of x?
Yeah.
Yeah? Okay. And you said that g of x is decreasing? Any more? Okay. All right. All those are good. All those work. All right. Clarita, I think we should make a table to compare the two functions. I've added a column. Actually, what she did is she added a row. Rows are left and right. Columns are up and down. Okay. She added a row, okay, to her previous table. So now it's completed. So we did this one before, right? We were dividing by 2, and then we said this was 1/2, and then this was 1/4, and then this was 1/8, and then this was 1/16. Right? We did that one before. Okay? All right? So 1/2 to the x power. Well, let's start at 0. Right? Okay? Anything to the 0 power is 1. So that one's going to be 1 right there, because that's my 0. Plugging in 0. Okay? Let's plug in positive 1. 1/2 to the first power. 1/2. Okay? So now, do we have enough to establish what the pattern is? If so, somebody shout it out loud.
We're going by
What do you mean I'm going by halves?
half. Like you're either adding a half or subtracting half.
Okay? If I'm adding a half, so if I would be adding a half if I'm going to the right, subtracting half if I'm going to the left. I will agree that that is a pattern. Yes. Okay? So let's plug in 2 to verify that pattern. Okay? So if I plug in 2 here, this would be 1/2 to the second power. Do you agree with that? Okay? Which would be, in math, that means 1/2 times 1/2. Do you agree with me on that? What is 1/2 times 1/2? No? It'd be 1/4, right? Because we multiply across the top, multiply across the bottom. So this would be 1/4. Does your pattern of adding or, oops, I put 1/2. Does your pattern of adding or subtracting a half hold anymore? Give you another chance. No, because it's not adding and it's not subtracting. Okay? Did anybody else now see a pattern? Which way? If I'm going to the right, I'm multiplying by 2. Okay? Would we agree with 1/4 times 2 is 1/2? 1/2 times 2 is 1. So what would the next one then be? 2, then? Okay? So if I'm multiplying by 2 to go to the right, what am I doing to go to the left? I'm dividing by 2, yep, or multiplying by 1/2. Do you notice anything about those two rows? The F row and the G row? What do you mean it's flipped? So one starts with 16, the other one ends with 16, right? Yeah, like that. Okay. I didn't know if you meant flip that way or if you meant like the fractions were flipped. Okay? Because guess what? The fractions are flipped. 16 reciprocal is 1/16. 8 reciprocal is 1/8. 4 reciprocal is 1/4, so on and so forth. 1/2 reciprocal is 2, and something like that. So yeah. So I wanted to make sure which flip you meant there, because both actually worked out. Okay. Right? Any differences? Could use the differences that we had in the last one, right? One's increasing, one's decreasing. Okay. Yeah, I like it. Love it. Okay. Now we're going to jump ahead a little bit here to number 9, and which is on page 23. Carlos just figured out that he can write 2 different exponential rules for the same function. Okay? Carlos has already written the rule g of x equals 1/2 of x for this function. Okay? The other rule then that he could write would be f of x equals 2 to the negative x power. I did 2 things. What are the 2 things that I tweaked to g of x to make f? I did 2 things. 2 things to g to make f. I flipped the base, right?
Yeah.
Or let's use a better mathematical term than flipped. I reciprocated the fraction. Yep, okay. All right, so I reciprocated the fraction, which then what did I have to do then consequently to my exponent? I had to make it negative. I got to go opposite with that. Okay? So if I flip, and that's the negative exponent rule that we learned a couple of weeks ago. Okay? When we said if we want to make an exponent positive, we just reciprocate the fraction or reciprocate the base. Okay? So really that's what we did. Okay? All right. So number 10 here. This one now is, so I'll start with, let's get off of the h's and the g's. I'll start with h of x here is 2 to the x power. That's what that function is. Okay? What would the other way of doing it, or of writing it? First off, let's come up with a name. We need a name for our function. Not h, not f, and not g. So we need a name for the function. So we can't use x either, because we already got x. So you got 26 choices. Don't everybody choose at once. What do you got? Z, love it, okay? So z of x then would be what? So that we get the same graph. What's the first thing that we did? We reciprocated it, okay? So what's the reciprocal of 2? 1/2. So then that's going to be 1/2 to the negative x power. truthfully, you got to look at two things in order to answer question number 11. Okay? The first thing that you have to look at is you have to look at the positivity or negativity of the exponent. Okay? If the exponent is a positive, then the base that the exponent is on has to be bigger than 1. So if it's positive x in your exponent, the base that that exponent is on has to be bigger than 1 for it to be grown. Okay? If that exponent is negative, then that base has to be between 0 and 1, but not including either one of them. Okay? Because you can't have a base of 0 and you can't have a base of 1. Okay? Your homework, you can start the 2.5 homework if you want, okay? But technically, we're not going to assign it until tomorrow. Okay?